Hi, welcome to part 2 of Graphing Quadratics with Mr. Hanna. What we're doing in this part is an alternative method for graphing quadratics, but perhaps more importantly just understanding how the graphs of quadratics sort of came about. So in particular we're going to start off by looking at the most basic possible quadratic, which is y equals x squared, and then we're going to do various things to it and see what sort of change that has in the graph of y equals x squared. Okay, so let's begin. Let's just graph y equals x squared. Alright, and this will be something you would have seen before, I imagine. X squared. There we go, there it is, x squared. And it looks just like that. So now let's press tab so we can graph something else. So we're now going to change it slightly. So we'll put a negative sign in. Y equals minus x squared, just like that. Okay, let's see what effect doing that has. So we'll do negative x squared. There we go. What's happened is that it's been reflected across the x-axis. It's been reflected across the x-axis. So this is what we call a reflection about the x-axis. Okay, so reflection about the x-axis. Okay, so now what we're going to do is thinking about our original y equals x squared here. We're now going to do y equals 2x squared. See what happens there. So tab again, and we'll go with 2 times x squared. Oh, look at that, it's the same, but it's just skinnier. So now let's do another one. Let's try y equals, let's try y equals 3x squared. Oh, there we go, it's even skinnier again. Let's try y equals half x squared. So let's do half. Let's use our fraction input, half x squared. And there we go. It's become sort of fatter, if you like, more wide. Okay, so what this is called is a dilation. So it's dilation, and here it's got a factor of dilation of 2, so that means so it's kind of skinnier, if you like, skinnier. And if we had a fraction, so let's just use a different number, 3, that would then be sort of fatter. And let's look at sort of the effect of making it skinnier, I suppose, is if you put in the same number for x. So if we go back here, if you put in the same number for x, so this blue one here, now to get your output has become higher up, so it's being times by 2. So if we want to, we can combine a reflection and a dilation. So on a new page, I'm going to be putting in y equals x squared, our original, and then I'll also put in y equals negative x squared on 3. And let's see what happens. So let's use a new page. This one's getting messy. So we'll start with x squared. There we go. And now I'll put in our negative fraction. Thanks. X squared divided by 3. There we go. So now it's fatter and it's been reflected in the x-axis. So we've done both a reflection and a dilation. And that is what you can see. Okay, so the next thing we're going to be looking at is translations. Translation. And translation basically just means moving it around. So we can either move it left or right, or we can move it up and down, or we can do both things at once. So let's try moving it up or down. So we'll start with x squared, but then we'll go, well, say plus, say 3. What's going to happen here is it's going to be shifted up 3 units, up 3 units. Let's find out if that's what happens. We've got our x squared plus 3. And yes, you can see in blue there, it's exactly the same as this yellow graph, but it's shifted up 3 units. So there you can see it a bit more clearly, it's just been shifted up 3 units. And if we wanted to, we could do x squared minus 2. Let's try that. X squared minus 2. And what do you think is going to happen? That's right, it's just shifted down. So shifted down 2 units. So there's our up and down, pretty easy. Now we're going to try is our left and right. So let's see what happens when we have x plus 1 squared. What do you think will happen? Will it go left or will it go right? Well, let's find out for ourselves. So let's start with an x. Oops. Okay, so there's our x squared. Now we'll pop in an x plus 1 squared, and look at that, it actually went to the left. Now let's think about why that is. Let's think about why it went left. So if for our x value we put in, let's say 1, if we put in a 1 to our x, then it will become y equals 1 plus 1 is 2 squared. So that's if x equals 1. So for x equals 1, y equals 2 squared. So 1 has become, the effect of putting 1 in, it's like it was actually a 2. So 1 becomes like it was a 2. And so that also means that this one here, negative 1, becomes like it was a 0. So what is now a 1, this value here, is the same as what a 2 would have used to be over here. So hopefully that helps. But just remember that if you've got something that's a plus, it'll go to the left. Or if we had y equals x minus 2 squared, for example, that goes to the right by 2 units. 2 units to the right. So all this stuff, the reflections, dilations, and translations, they fit perfectly well. They're just an explanation for why our different forms work. Our different forms of the expanded form, factorized form, and turning point form. This is sort of the explanation for why those forms actually sort of work. Alright, that's it for now.